So 5b, this is what we just did. So let's see how you're doing with it. What is the equation?
Is it x?
It is x because it's vertical. Yes, great job.
Wow.
Okay, so when it is a vertical line, it is x equals, okay? X equals 5. What would the second one be?
Y equals negative 1.
Great. Y equals -1, right? It's a horizontal line. So this is bucks. It is vertical, so it's x equals. This is oi. It is a horizontal line, so it should be y equals. Okay? Okay, this one. It says transform the equation into standard form using integers, okay? Now, what's an integer?
Number.
What kind of number?
Positive.
Doesn't have to be positive. A whole number, but positive or negative, right? Integer would be like -16, +4, -2, 0. Those are all integers, okay? In other words, you cannot have a decimal, you cannot have a fraction if it's going to be an integer. So we're going to be getting rid of fractions today. Doesn't everyone love getting rid of fractions? All right, so this first type of problem, it says transform this into standard form using integers, okay? The problem is there is currently a fraction in this equation. So what you're going to do is you're going to multiply everything by your denominator, okay? So this whole thing times 7 and the other side of your equation times 7, right? Because the golden rule of math, whatever you do to one side of an equation, you must do to the other, okay? If you're going to change your equation, you got to do it to both sides so they're still equal. So right now, we would have this, 7y on the left. Now, that 7 has to get distributed, and this gets tricky for some people. Think of it like this. This is 7 times -3/7. If you treat that like a fraction, 7/1 times -3/7, what does that equal?
3.
-3, right? The 7s would reduce to 1, and you get a -3. So here's the beauty of this. If you're multiplying by the denominator, what you're left with is what you're left with, right? The 7s go away, and you get a -3x, okay? Now, don't forget to distribute that 7 because that 7 now has to be multiplied by the 5 also. So plus 35. Okay. Now, it says to write it in standard form. Do you remember what standard form looks like? AX plus BY equals C. So is this in standard form? No. We can make it standard form by doing what? What?
Subtract 35?
I wouldn't.
You add 3.
I would add the 3x, right? Move the x over to the left by adding it. So plus 3x and plus 3x. So what you're left with on the left is 3x plus 7y. This is 0. What you're left with on the right is 35. That is standard form. Okay, so you start by multiplying by the denominator, and then you rearrange once the fraction is gone.
I thought we were going to have fractions.
That's the point. We're getting rid of the fractions. Standard form can't have fractions, right? So there's a fraction to start. We're getting rid of it. That's what I said. We're getting rid of the fractions. Okay, so that is if it's in slope-intercept to start, right? This started in slope-intercept form.
And then are we gonna like from that, from like 3x plus 7y equals 35, then are we gonna find like x-intercept and y-intercept?
No, not for this. This is just rewrite it in standard. I mean, they could go further and ask you to do that. I don't typically put all of that together. I usually break it into, can you put this into standard form? And then on a separate question, could you put this and find the x and y intercepts? Okay, what form is this?
Y1, y-intercept. Y minus y1.
Point slope, right? So this one is starting in point slope form. But again, they want it in standard form. So we're going to essentially do the same thing with just one extra little bit of steps on the front end. Personally, I like to distribute and then get rid of the fraction. Yeah, maybe that's not the best way. Maybe we multiply. Would you distribute? I feel like you're... No, we should. You did? You multiplied right away? Did you remember to put parentheses around it then?
Yeah.
Did you, Joaquin?
I just multiply both sides by
-3. Okay, let's do that. Let's just do it. I believe in you. You got this. Okay, so here's the deal. If we're trying to get rid of a -1/3, the way we do that is you're going to want to do this. You're going to multiply by a -3, right? Because that will make this equal to 1. The tricky thing doing it this way, the thing that I hesitate to do it this way for, is you don't need to distribute that -3 because you multiplied it by this thing out in front. That takes care of it, okay? So if you don't love this method, I'll show you the other way as well. But you would multiply both sides by -3, so it's -3 times y minus 2 equals, and then all you're left with over here is x plus 6, because the -3 and 1/3 got multiplied and they reduced to 1. Okay? If you do it this way, then I would distribute, so -3y plus 6 equals x plus, 6. Typically, it's preferred that you have less negatives. So the book would move this 3y over to this side. So it's x plus 3y plus 6 equals 6. Then they would move the 6 over to the other side and get 0. And that would be your standard form, okay? 0 equals x plus 3y, or you could write it like this, x plus 3y equals 0, okay? If that way is tricky for you, I'm going to show you the other way too right now. The other way you could have done that one, so if you liked that way, ignore me right now. If you didn't love this way, here's the other way you could have done this problem. Okay, starting with this, you can distribute your -1/3. So y minus 2 equals -1/3 x, and then a -1/3 times 6 is going to be a -2. Okay. Now get rid of the fraction. So now if you want, you can multiply both sides by a -3. So you get -3y plus 6 equals, that's 1, x. -3 times -2 is a positive 6. Okay, and now we're right back where we were here. So it's up to you if you would rather get rid of the fraction first and then rearrange, or if you want to rearrange and then get rid of the fraction. But we would add the 3y, so x plus 3y, and then we would move the 6. So either way, you're going to get back to the same equation, right? These are the same equation. It's just up to you what you like to do better. Just out of curiosity, how many of you think you'll do the first way? How many of you think you'll do the second way? Okay, so we're split a little bit. That's okay. It's the beauty of math. Don't have to get there just one way. All right. This says, what are the x and y intercepts of the line that passes through this? Okay, now, if you have 2 points, what is something you can find with 2 points? You could find the slope, okay? So if we start by finding slope here, this would be x1, y1, and x2, y2, okay? So we're going to go y2 minus y1 over x2 minus x1. What's 2 minus 8? -6. What's 4 minus a -2? A positive 6. So you have a slope right now of -1. If you have a slope and you have 2 points to work with, what would you do next? If we're trying to get to standard form, but we can't yet. You could do point slope, or I showed you another way too. You could do slope intercept, okay? How many of you would prefer to plug this information into point slope form? Y minus y1 equals m times x minus x1. Okay, how many of you would prefer to plug this into y equals mx plus b and solve for the b? Okay, so I can show you both. I don't care which one you do. They're both going to work and you're going to get the same answer. So it's up to you. If you're going to do point slope, here's what you would do. You'll go y minus your y1. Do you want to use this? Do you want to do the other point? I am recording, yeah. The other point? Yeah, it's nicer numbers, huh? Okay, we'll do this one. Y minus 2 equals the slope, negative 1, times x minus 4. Okay, but now we want to turn it into standard. How do you turn that into standard form?
Negative 1 times x.
Right, we're going to distribute. Okay, so y minus 2 equals negative x plus 4. Okay, then I would add the x to both sides, and I would add the 2 to both sides. So I'm going to get over here, x plus y. Over here, I get a 6. So that is your equation in standard form. If you like slope-intercept better, let me show you. Okay, slope-intercept form, we would do y equals mx plus b. What is m?
Slope.
Which is
Negative 1.
-1. So if I'm going to do this using that same point, this is your x, this is your y, so it would be 2 equals -1 times 4 plus b. So simplify that. 2 equals -4 plus b. So add the 4, and you get a b value of 6, okay? So if I put that into slope-intercept form, that means the -1 goes here, and the 6 goes here. So y equals -1x plus 6. So now you have slope-intercept. We want standard, so you're just going to move that -1x over. So it's going to be a positive 1x, or just x, plus y equals 6. So you can see you get the same equation, okay? X plus y equals 6. It is up to you which route you prefer. You can start with point slope, or you can start with slope-intercept. You'll get to the same place. Questions on that?
I didn't write it.
What?
I didn't write it.
Okay. Okay. Last thing is, how do we do this with a word problem? And I feel like this will come into play more in chapter 6. You'll see word problems more with this type of thing. But let's just introduce you to it. So example 3, it says Apple sells songs for $1 each and movies for $12 each. And you have $60 to spend. Write and graph an equation that describes the items you can purchase. What are 3 combination of numbers of songs and movies that you could buy? Okay. So I'm going to call songs S. I'm going to call movies M. Anyone think they can turn that into a standard form equation? I think you can. $1 per song and $12 per movie, and it has to equal a total of $60.
1s plus 12m equals 60.
Yeah, 1s plus 12m equals 60, right? That would be your equation. The question they ask is, what are 3 combination of numbers of songs that you could use? Now, I would probably try zeros to start. because zeros help a lot. So if I bought 0 songs, so $1 for 0 songs, it's kind of like the cover-up method, right? Then 12 times M would equal 60. So one of those options, if 12M equals 60, how many movies could you buy? 5, okay? So that means if you bought 0 songs, you could buy 5 movies. We'll just make that an and. Okay, so that's one combination of songs and movies that would get you $60. What could you do for another set of numbers?
1s plus 12 times 0 equals 60.
Yeah, plug in 0 for your movies. 1s plus 12 times 0 equals 60, okay? So this would be s equals 60, and there's nothing to divide by because it's 1s, right? So you could buy 60 songs and 0 movies. That would be another combination, okay? I'm not even gonna make you graph this right now. They want you to graph it, but I'm not gonna do that because I feel like we're pretty done. But that would be 2 combinations. Now, the reason graphing it can be nice is when you graph it, then maybe you see another place that it perfectly hits the crossbars, so you could see how many songs and movies the combination would work for. But you can also do kind of a guess and check with that. So let's say we wanted to do 2 movies, right? Then it would be 1 times the number of songs plus 12 times 2 movies equals 60. If you solve that equation, this is 24, right? So take away 24, and you get S equals 60 minus 24 is 36. What is that combination? 36 songs and what? 2 movies. Okay, so that would be another combination, 2 movies and 36 songs. So you can always just kind of guess and check, like try a number, see what it gets you for your other number, and that'll get you your combinations. Okay, we're not gonna solve this last one. We're just gonna write the equation. It says you got $100 for Christmas to buy clothes. T-shirts cost 15, pants cost 20. What would your standard form equation be? 15T plus 20P equals 100. $15 per t-shirt plus $20 per set of pants equals $100. Okay? Questions on that?